Welcome back everyone to the last video of our class today. So our last video is talking about the operating variables that could be varied during a collisions process. Here, we are going to introduce four major parameters that could be varied. The first one is about temperature, next, acid strength, isobutane concentrations, and lastly, olefin space velocity. So when we talk about the temperature, actually we have come up with a general statement. Lower the temperature, higher the octane number of the products that we obtain. So I repeat again, the general statement in describing the effect of temperature. Lower the temperature, higher the octane number of the products that we obtain. So for your information, the temperature will be very significant in affecting the alkylation process that using sulfuric acid as the catalyst. For your information, since just now I think that lower temperature will favor the reactions, isn't it? So what happened is that if the temperature too low, what happened? It will causing a reduction of the it will causing an increasing acid viscosity. So it will actually lower the temperature. It makes the acid to becomes more viscous. What will happen when the acid is too viscous? The visibility between the catalyst and reactants will be reduced. So this that now, if the temperature is too low, the catalyst and the reactant itself, they are not able to be homogeneously mixed. So in the end, the reactions will be sacrificed. So in the end, the products that we obtain will reduce in quality as well. So now we try to think, if let's say now we want to improve the visibility, probably we try to think, increase the temperature. But the problem is like this. If we increase the temperature, what will happen? Actually, it will causing a polymerization of olefins. So for your information, don't forget olefin itself contains C double bond. So usually it's very reactive, isn't it? So a higher temperature, actually it will promote a polymerization of this double bond. So here, the effect of temperature is very easy. Basically, a lower temperature will favors productions of higher octane number gasoline product. But if let's say temperature is too low, what happens is that the acid itself will become too viscous. Then the acid itself will be poorly mixing with our reactants. But if the temperature is too high, let's say for example more than 21 degrees Celsius for sulfuric acid alkylations, what will happen is that olefins will be polymerized. Then it will form tar, T-A-R, tar. So this is a summary of the first operating variables, temperature. Then we proceed to the next one, acid strength. So acid strength actually could be something indications of the purity of the acid. Usually the acid itself will contain water and also some hydrocarbon. But basically the acid strength refers to the purity of acid. A lower acid strength means that the acid that contains high amount of water, and a strong with a high acid strength means that the water content is lower. So now the major factor that will determine the efficiency of alkylation process is about the water content in an acid. For your information, the water itself actually is an inhibitor, or usually it can reduce, what we see is that it will reduce the catalytic activity. So the presence of water actually sometimes is not favored because it will reduce the catalytic activity of the acid itself. So what we claim is that the higher water content, actually they will reduce the conversions. So next one, we are going to talk about isobutane concentrations. For your information, isobutane concentration actually is an indication of the ratio in between isobutane and butane. Actually, it means that actually butane concentration is means how much of isobutane presented in the reactant itself, reactant stream, inlet stream. So it's the ratio of isobutane to butane. Usually, a high ratio is favored for a conversions, for a higher conversions and also productions of the product with higher octane number. So for your information, usually the isobutane will be fit in excess if compared to the butane itself. So usually the ratio that we promoted is around 5 to 1 or even up until 15 to 1. So I repeat again, a higher ratio of isobutane to butane, actually it will encourage, it will promote higher conversions, and also it will produce the fuel, gasoline fuel with higher octane number. The last one, olefin space velocity. So we already encountered so many times talking about space velocity. Usually we talk that actually is the mass flow rate of the reactants ratio divided with the mass of catalyst. But in this case, since the catalyst itself, they are in liquid form, and then olefins, for your information, all the reactants in a collision process, they are actually in liquid phase. So in this case, the olefin space velocity will be the volumetric flow rate of the olefins divided by volumetric of the catalyst, which is the sulfuric acid or hydrofluoric acid. So for your information, in general, lower space velocity will produce a product with higher octane number. So lower space velocity, it will produce a product with higher octane number. Okay, so why does it happen? For your information, if let's say we have a higher space velocity, usually we will produce a paraffin which has longer hydrocarbon chain. I repeat again, where can I write? Higher olefin space velocity, what will happen? It will produce a longer chain hydrocarbon. So, do you still remember last time we we try to determine the research octane number based on the table, isn't it? And we try to compare in between a straight chain paraffin and then with a low molecular weight with a high molecular weight. And then we found out that actually higher the molecular weight of a straight chain paraffin, then the lower the octane number, isn't it? So for your information, higher olefin space velocity, actually it will promote the productions of the longer chain hydrocarbon, which in the end will sacrifice the octane number. So in general, a lower olefin space velocity will produce a fuel which has a higher octane number. So in general, we have 4 operating variables, isn't it? Temperature, acid strength, isobutane concentrations, and also olefin space velocity. For your information, these all variables, they are actually very important, isn't it? This is our CRO tree. So definitely, these all parameters could be included in our final examinations. So that's all for the class today. Don't forget to click the Google form link that I attached in the post. Click it, answer it, submit it before 9:30. So I need to receive all of your responses at around 9:30, and each of your responses, they are considered, it is a proof that you attended the class today. So thank you very much for your attention. See you all again on next Wednesday. We are going to chapter 7.